All right, here we go. Sample space and probability. In this section, you can't see what I'm doing with my hands, but I'm doing something. Sample space, we're going to figure out what that is, but we're going to figure out what probability is. We'll need the words sample space. Those are key vocabulary words that we're going to need to describe probability. So, first, what is probability? What is probability? Well, it's the likelihood that something's going to happen. Hey, what does likelihood mean? It means how likely is it to happen? Is there a really high chance of it happening, or is there a really low chance of it happening? The description of the high or low chance of it happening, that's called likelihood. So there you go. Probability is the likelihood that an event will happen. The higher the probability, then the more likely, the higher the chance it's going to happen. Like it's probably going to happen. Or if you have a really low probability, it's probably not going to happen. It doesn't mean that it won't happen. It means that it's just less likely to happen. But it could still happen. Anything can happen. Unless you have a probability of 0, then for sure it will not happen. So that's what probability is basically. It's the measure of the likelihood. So then maybe your next question is, well, how can we calculate probability? And that's what, look at that. How do we calculate probability? There's a mathematical way to calculate it. We define it first, and then we can calculate it. So let's take a look. We are going to have a fraction, but before I explain what that fraction is, you can consider probability a percent, but most of the time, a lot of people talk about percents for probability. There's a 50% chance that this will happen. There's a 20% chance that this will happen. But you can talk about it as a fraction as well. And hopefully we can go between fractions and percents fairly easily so that you can be comfortable with each. But the way we define it to calculate is with a fraction. So we usually think of probability as a fraction, but you can make it a percent as well. We're going to look at the fraction, like the definition of it. So to calculate, and this is the fraction, I can't stress this enough, this is the fraction. You have one number on top and one number on bottom. That's why I made them different colors. This is the dividing bar. It's a fraction. So to calculate this, we say perhaps, actually let me read this. It's the number of ways to achieve a desired outcome, so the number of ways that something you want to happen, the number of ways that can happen, divided by, over, the total number of things that could happen, the total number of outcomes. Outcomes are just results of probability experiment. So if I say, maybe I'm playing roulette. I don't know if you know what roulette is, but suppose I want an even number. Then on the roulette wheel, I would have to figure out, if I wanted to know the probability, I would want to know the number of even numbers on the roulette wheel so that I could land on an even number. And then I would want the total numbers that are on the roulette wheel, because it doesn't have to land on an even number, it could land on an odd number. So this is the number of ways where you want something to happen. If I said, what's the probability of, on a roulette wheel, that the ball lands on an even number, I would first have to know the number of even numbers that it could land on, and then I would also have to know the total number of numbers that there are on the wheel. And it's usually a little bit less than 50%, so it's not that great. All right. Or maybe it is 50%. I don't know. Okay, so that's how you calculate probability, and hopefully we'll do enough examples to where this makes sense. But there's something else that I want to say with this fraction, with this probability fraction. The top number here is always going to be smaller than or equal to the bottom number. It can never be bigger. You can never have an improper fraction. You can't have more than 100% chance of something happening. That doesn't make sense. So in this context, it doesn't make sense. So the top number is always going to be smaller than or equal to the bottom number. And the bottom number is always the total, and that's called the sample space. So it's always going to be the total. Just like with percents, the bottom is like 100%. That's the same idea with this. The bottom is always going to be the total number. And that one's called the sample space. The top number is called the event space. That's the number of ways that your desired event could happen. And then the sample space, again, we said this before, the sample space is the total number of outcomes, the what could happen, like the number of all the things that could happen. So let's take a look at our first example. Find the number of outcomes in the sample space. So again, sample space, this is something to remember. The sample space is the total number of outcomes. I might quiz you on that. It's the total number of outcomes. The event space is the number of ways to achieve a desired outcome, a specific outcome. All right, find the total number of outcomes in the sample space. So suppose you flip a coin and roll a six-sided die. On the dice, or rather on the die, you have six sides and you roll it. You can land either 1, 2, 3, 4, 5, or 6, and the coin has heads or tails. So name all possible outcomes. So I guess the first thing you could do is just think about the coin. You could either land heads or tails. So what we're going to do now is called a tree diagram for all possible outcomes for the sample space. So the first thing that I'm thinking of is, well, I can land a heads or a tails. But remember, I'm flipping a coin and rolling the six-sided die. So it's not just like heads, tails, that's two outcomes. No, because I also have to roll the die. Well, if I'm rolling the die could either land on a 1, or 2, or 3, or 4, or 5, or 6. So let's just consider the case where we're just landing on heads. What could happen with the die? Well, I could have a 1, 2, 3, 4, 5, or 6. Like I could have flipped the heads and could have landed one of those 6 outcomes. Or I could have flipped tails and then also gotten 1, 2, 3, 4, 5, or 6 on the die. So total, what is the total number of outcomes? There are 12 total outcomes. The sample space is 12 because I could have done heads 6 different ways with the 6 different numbers on the die, or I could have done tails in 6 different ways. 6 plus 6 is 12. So find the number of outcomes. The number of outcomes is 12. We have 12 possible outcomes, and it also says to list the possible outcomes. So, I mean, I guess this is a way to do it, but we could also, I'm just going to say H1 for heads, and we could roll to 1. H2, H3, and so forth. And so there we have all possible. And then let's just count them to make sure we got them all, because there should be 12. We decided that there's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So there are 12 possible outcomes. That means the sample space is size 12. There are 12 outcomes in the sample space, and there they all are. Hopefully that makes sense. Later on we'll use that as the bottom number. The 12 would be the bottom number because that's the total number of outcomes.